Hi guys, this is Mr. Holly. Today we're going to be looking at the relationship between part, whole, and percent. And we're going to be doing problems where you are finding each of these. You might be finding the part, you might be finding the whole, you might be finding the percent. So we're looking at the relationship between these three quantities. Some examples of this we're going to go through here. And on this first part, all you're doing is just trying to identify what's the whole unit as we are talking about percent, as we continue our study of percent. We're looking here, what is our whole unit in these 6 different scenarios? So for instance, 15 is what percent of 90? Well, here's your part. What percent, we don't know the percent, of 90. So that is the total. So 90 would be our whole unit that we're trying to find the percentage of. What number is 10% of 56? 56 is the whole unit. We know the percent, we don't know the part. 90% of a number is 180. So 90% of some number, that would be the whole amount, right? Whatever this number is, that whole number is 180. So 180 is just 90% of some whole thing. We don't know what it is. I'm going to put X or a number. All right. Moving on to the next one. A bag of candy contains 300 pieces. 25% of the pieces in the bag are red. So the entire bag is 300 pieces. That's the whole thing. 300. 70% of the students earned a B on the test. So the total number of students, these students, that would be the whole thing. So there's X or whatever, it would be these students. Whatever the number of students is, that's the whole unit. The 20 girls in the class represent 55% of the students in the class. So 20 girls are part of the class. 55% is the percentage of the class that they make up. And the whole thing is the number of students in the class. So students in the class. Students in the class would be our whole amount. Okay, so let's look down here at the bottom, and we've got basically the same question, or excuse me, the same scenario asked 3 different ways. In one way, we're going to be given the part, the percent, like in each of these different scenarios, we're going to be trying to find a different piece, the part, the percent, or the whole. In the first scenario, it says 40% of the students, so here's the percentage, 40% of the students on the field trip love the museum. If there are 20 students on the field trip, how many love the museum? So this is the percentage and the whole. We want to know the part. So percent is 40%, the whole is 20. We want to know the part. When we are looking for the relationship between part, whole, and percent, this is the equation that we're going to use. The part is always equal to the percent times the whole. Okay, so if you think about that, the percentage is being multiplied times the whole thing. So if I want to know what percent of something is the part, right? This percentage of something is the part. That's the relationship. It is a application or a variation of what we've already talked about with this idea of like y equals kx, where x is our whole, y is our part, and the percentage is like the constant rate between them. Like the percentage is the rate that we're trying to see if I'm comparing the whole to the part at this rate, at the rate of k. Okay? So what I mean by that is, let's say I want to find the part if 40% of the whole liked the museum. Well, my part is equal to 40% or 4/10 of the whole is 20. That means the number of students, 4/10 of 20 is 8 students. So 8 students like the museum. 40% of the students on the field trip love the museum. 40%. If 20 students love the museum, how many students are on the trip? So this is just part of the number of students on the trip. So we don't know the whole, we know the part. So here I can use the same equation, the same relationship. I can do the second one. I can look at if the part that actually enjoy the field trip is 20, that is equal to 40% of what? 40% of what? I don't know. So how do I solve for that? Divide by the coefficient, divide by the coefficient, and x is equal to, I believe 20 divided by 4/10 is 50. It is 50. So that means 50 students went on the field trip. Here we have another one. 20 students on the field trip love the museum. That's part of the students. If there are 40 students on the field trip, well, that's the total number. What percent love the museum? Well, 20 out of the 40. So let's stick with this structure, but then I'm also going to teach you like a variation of this, okay? We're sticking with this structure of part equals percent times whole. I'm actually just going to write it out like that. Part equals percent times whole. Part equals percent times whole. And I think you guys should make a habit of writing this every time. And if my part is 20 and the whole is 40, well then to solve for this percentage, I would just say divide by 40, and 20, I'm going to bring this over here, 20 over 40 is equal to my percentage. Well, what is 20 over 40? That's 0.5. So my percentage is 0.5, which as a percent, 5/10 as a percent is 50%. You should have that from yesterday when we did decimal conversions to percentages. So when I get 5/10, I need to convert that to a percent. The quick way is like to multiply by 100. Whatever your decimal is, if you multiply by 100, you get your percent. But you should have a better understanding of that from yesterday's lesson. Okay, so let's actually look at some problems that are related to percents. Remember, we want to know part, whole, percent. We're using this equation. Part equals percent times whole. And if we go to that last, well, let's do that later. In Ty's math class, 20% of students earned an A on a test. So we know the percentage. If there were 30 students in the class, how many got an A? So I can just come down here. Part equals 20%, 2/10, times 30. 2/10 of 30, the part that got the A, 6 students. Now we can think about that in a variety of ways. I want to just kind of draw it out for you to help you see it. It'd be really nice if we had 100 squares here, because that's percent is out of 100. But let's just look at it visually. So let's pretend that this long rectangle represents the whole thing. That whole thing is 30 students. Now we're told that we're looking for 20% of the students. So think about 20%. How many 20% would it take for us to have this entire block filled up? 20, 40, 60, 80, and 100%. So each of these is worth 20%. If I was to divide that up into 20 sections of 20%, and then if I count those sections, that's 1, 2, 3, 4, 5 sections. So that means 30 divided by 5 is 6. You can see that visually, but that also makes sense because what is 20%? Well, 20% is 20 out of 100, which is 1/5, right? So this question is really just asking if 20% of the students got an A, that's really 1/5 of 30, or 30 divided by 5, which is 6. So you kind of see all of that fraction, decimal percent, visually in this model. Hopefully you're able to kind of connect between the fraction, decimal percent pieces here. Okay. Let's try another one. In Ty's art class, 12% of the Flag Day arts projects received a perfect score. There were 25 art projects turned in by Ty's class. How many of the art projects earned had a perfect score? All right, part equals percent times whole. What are we provided with? Percent, whole. Part equals 12%, which is 12 hundredths, times the whole of 25. And the part that received a perfect score was 3 art projects. Twelve hundredths times 25, 3 of them. You could do that in a diagram like we did above as well. It would be a little more difficult because we are talking about, maybe you would break this up into 25, do the whole thing. I'm not going to do this, but maybe you break it up into 25 squares, right, for the 25 projects. And then you would realize each of those is worth 4%, and you could count. Each project is worth 4%, so you'd say 1, 2, 3 projects would be 12%. So we could potentially do some kind of diagram with that as well. We are not at the moment. Okay. Let's look at another one. In Ty's English class, 70% of students completed an essay by the due date. There are 30 students in Ty's English class. How many students completed the essay by the due date? Part equals percent times whole. What percent? 70%. What is the whole? 30. So what's the part? Well, 70% of 30 is 21. And you can just do this in your calculator at this point. That's okay. So 70% of 30 is 21. Good. I'm not going to get deep into example 3 just yet. Let's skip that and let's look over here at example 4. We have enough time to do this, I think. On example 4, we're now going to get different information. Zoe inflated 24 balloons for the high school dance. If she has inflated 15% of the balloons that are inflated for the dance, how many balloons are there total? So we don't know the total now. So now we know the part is equal to percent times whole. We know the part. The part is 24, and that is 15% of some whole. We don't know what that is. What's the whole? I don't know. I'm just going to put an X here for the whole. Now, to solve, I would divide by the coefficient, and I'm solving for X. So 24 divided by 15 hundredths is 160. So there would be 160 balloons total. All right. Now, could we do that as a diagram? Sure. Think about it like this. I can't get to 100 using 15%, right? But I could get to 100 using 5%. If 15% is 24, 5% would be 8, right? So I could say like 8 is 5%, right? So then if I wanted to know